video we had talked about in the previous video basically we had talked about your hypothesis testing. Okay, hypothesis testing. So in here I had explained what is a hypothesis and why do we need to test it, and how important it is in statistics and econometrics to test a hypothesis. So the first thing is that you create a hypothesis or an assumption and then you test it. So whether the hypothesis that you have created, is it significant or is it not significant? Uh, so whether you reject it or you do not reject it. So that is the idea of hypothesis testing. How do we test this hypothesis? That would be the agenda for today's video. So basically we use two approaches. So in here we'll be talking about these two approaches only. So the first approach is that we have already discussed in the previous videos is your confidence interval approach. So one of the approaches, the confidence interval approach, and the second approach is your test of significance approach. So these are the two ways through which we'll try to test a hypothesis. So let's talk about the first approach, that is your confidence level, confidence interval approach. So in here what happens is, suppose you create a null hypothesis which says that the value of beta 2 is your 0.5, and the alternative hypothesis says that no, the beta 2 value is not equal to 0.5. So this not equal to corresponds to a two-tailed test. Okay, so we'll see why. So if I have to create an interval, okay, so my beta 2 value will lie in a range. So this range will be either below some value lower than beta 2 and some value more than beta 2. Okay, so when I plot this diagrammatically, the graph will come out to be like this. So there will be a critical area here and a critical area here. So if I say that my beta 2 is not equal to 5, it means that it can either lie in this range or in this range. So this is here. If suppose I have a 95% confidence interval, so this is your 95% region, and this is your 2.5% region, and this is also your 2.5% region. So this is when you say that beta 2 is not equal to 0.5. Had you said that beta 2 is greater than 0.5, okay, then you would have resorted to a one tail test. So you'll be talking about values higher than zero point 0.5. Okay, so on the upper range. So this is how your tests are defined. So whether you have to go for a two-tailed test or a one-tailed test depends upon the null hypothesis that you have chosen. Sorry, the alternate hypothesis that you have chosen. So in the confidence interval approach, we we create a interval where we believe that our true population parameter value might lie. So it can lie in this interval. Okay, so beta 2 hat minus t alpha by 2 into standard error of beta 2 hat and this range t alpha. So we had discussed how we create the t values, okay, and we make the use of the standard errors of beta 2 hat to estimate this interval. So if my beta 2 values are lying in this range, okay, and if I've chosen the level of significance at 0.5, so this implies that I'm 95% confident that my true population parameter, or there's a 95% probability that the true population parameter is lying in this range. So if the H naught says that my beta 2 value is zero point 0.5, so I'll create an interval around this zero point 0.5 or the beta 2 value of zero point 0.5 through this method, okay, through this method, and check whether, so I can choose any level of significance. If I've chosen zero point zero 0.05 level of significance, so I'll test the hypothesis for a 95% confidence interval. Okay, so if the value of beta 2 lies in this range, it means that I am not rejecting this null. And if the value lies beyond this range, so it's lower than this value, this critical value, or it's higher than this critical value, it means that I am not, uh, I am rejecting the null. Okay, so this is the confidence interval approach. So you'll have to check whether the true population parameter value is lying in the created interval range or not. If it's not, then you reject the null, and if it is lying in that range, then you do not reject the null. Okay, so this is how you test the hypothesis via the confidence interval approach. The second approach is your test of significance approach. Okay, so in here the difference is that, so in here we are creating an interval for the true population parameter. So the difference here is that, so you choose a value of beta 2. Okay, so you define a beta 2 value which is equal to beta 2 star, which is equal to zero point 0.5. That is your null hypothesis, which says, so you have chosen the value of beta 2, right? And using this value, you'll take a sample and take a value of beta 2 hat and check whether the t value corresponding to that beta 2 hat is significant or not significant at a given level of significance. Okay, so you'll understand this in a few seconds. So a test of significance is a procedure by which sample results, that is your beta 2 hat value, are used to verify the truth or falsifying a null hypothesis. So you'll use the beta 2 hat value to check whether beta 2, which is equal to zero point 0.5, is lying in a significant range or not. Okay, or the test t value corresponding to that beta 2 hat is significant or not at a given level of significance. Okay, so the key idea is to accept or reject H naught on the basis of the value of test statistic obtained from the data at hand. So with the help of data, you will find a value of beta 2 hat, and corresponding to that beta 2 hat, you'll uh, find the value of the t statistic, and you'll check whether the t value is in a given range, okay, with a certain given level of significance. So whatever level of significance you have chosen corresponding to that t value or the range of t value, whether your experimental t value that you have received from the data, okay, is lying in that range or not. So if it lies in that range, then you do not reject the null, and if it doesn't, then you reject the null. Okay, so the t value is calculated using So we have already seen this formula, which is equal to beta 2 hat minus beta into under root of summation xi square upon sigma hat and the degrees of freedom. So usually for beta 2 it's n minus 2 degrees of freedom. Okay, so if the value of true beta 2 is specified under the null hypothesis, the t value can be readily computed. So if I have the value which is zero point 0.5 here, I can easily find the t value and the probability associated with it. So the probability that minus of t alpha by 2 is beta 2 hat minus beta 2 star. So I've chosen the beta 2 star value, which is equal to the null hypothesis value upon standard error of beta 2 t alpha by 2. So which is equal to 1 minus alpha. So this is the formula of the probability that your experimental beta 2 hat value lies in this range. So what is the probability? So I have to test whether the beta 2 hat value is lying in a certain range around the specified beta 2 value, which is equal to zero point 0.5. That is the null hypothesis. Okay. And what is the probability of that? So if I'm taking alpha is equal to 0.05, it means that I am 95% sure, or the probability of beta 2 hat lying in a certain range around the beta 2 value, which is equal to zero point 0.5, is 95%. So out of the 100 samples, 95 times the beta 2 hat value will lie in a specified range around beta 2. Okay. So this, so I can rearrange this term, and it can look in a different way, which we have seen in the previous video. So I'm not solving it. So the interval will come around beta 2 hat, which is different from the previous confidence interval approach where the interval was around beta 2 values. Okay. Beta 2 hat values in here is the interval, or the so the interval that we are creating here is around beta 2 hat values. So let me just write it. Probability that beta 2, this is beta 2, wait, it's the probability beta 2 star minus t alpha by 2 standard error of beta 2 hat sorry, this is beta 2 hat beta 2 star plus t alpha by 2 standard error of beta 2 hat. So please mind the handwritings. This is beta 2 star, beta 2 hat, sorry. So we are creating a confidence interval for your beta 2 hat values. Okay. And we are checking the probability if the beta 2 hat values are lying in a specified range with a given level of probability. Okay. So the connection between the confidence interval and the test of significance approach to hypothesis testing is that in confidence interval procedure, we try to establish a range or an interval that has a certain probability of including the true but unknown beta 2. Whereas in the test of significance approach, we hypothesize some value of beta 2 and try to see whether the computed beta 2 hat lies within reasonable limits around the hypothesized value. So in confidence interval approach, we create a interval around beta 2, okay, and try to establish a range or interval around this unknown beta 2. Whereas in the test of level of significance approach, we create a interval around beta 2 hat. So we have to see whether this beta 2 hat value lies in a certain range, and this range is close to your hypothesized value of beta 2, okay, which is zero point 0.5, that the example we have taken till now. So this beta 2 hat value should lie within a reasonable range around the hypothesized value of beta 2. So this is the difference, okay, between the two approaches. So suppose there's an example where beta 2 hat is equal to 0.7240, standard error of beta 2 hat is equal to 0.0700, degrees of freedom is equal to 11, alpha is assumed to be 5%, okay, T alpha by 2 is 2.201, H naught says that beta 2 is equal to beta 2 star, which is equal to 0.5, and H1 says beta 2 is not equal to 0.5. So this is a two-tailed test. Okay, so you have all the values, so it's very simple if you have all the values to check. So we'll find the t values. Okay, so sorry, the t value will be 0.7240 minus 0.5. Okay, that is beta 2 hat minus beta 2 upon standard error of beta 2 hat, which is equal to 0.0700, which is equal to 3.2. Okay, so this is my t value for the given beta 2 hat, and I already have my t alpha by 2 value. Okay, so if I plot this on the graph, so this is my t alpha by 2 value, which is equal to plus 2.201, and this is my t minus alpha by 2 value, which is equal to minus 2.201. So this is my 95% confidence interval. So the value of t that I'm getting for beta 2 is 3.2, which lies in this range. It will lie in this range. Okay, so it means that my null hypothesis is rejected because uh, the t statistic for the given value of beta 2 hat is not lying in the specified range in which it should be lying. So I reject the null. Okay, so it means that my finding is significant. Significant. So whenever we reject the null, or when the t statistic of the parameter lies outside the interval or confidence interval created, it means that my findings are significant. So why is this the case that when we are rejecting the null, then we are saying that my findings are significant? It basically is because if you have a hypothesis, it means that you already believe in that thing or in that statement or in that intuition through which you have created this hypothesis. Okay. So if the results are actually, allowing you to not reject the hypothesis, it means that there is no significant change. So whatever you believe in is true. So there is no significant change, right? But if whatever hypothesis you believe in is being rejected by your findings, by empirical analysis, it means that your findings are significant. And that is why if you reject the null, it means that you have a significant finding here. So that is the idea of significance and not significance, non-significance. Sorry. So this was about hypothesis testing through the two ways, that is the confidence interval approach and the level of significance approach. I hope I was able to make some sense, and I hope you enjoyed the video. So we'll move ahead with the further learnings in the next video. Till then, take care.